Hi, welcome to my video on the type of data that's used in a relation. And that type of data could be, one type is discrete and the other one is continuous. Let's explain the difference. Discrete data is counting numbers. The set of natural or whole numbers are counting numbers. Let's do some examples of discrete data. And not only that, when you use counting number, that means your graph is, if you think about it, if you're counting, you can only have dots. Okay, let's explain. The cost of golf balls at $2 a ball. Well, let's go through these I'll go down through for A first, and then I'll come back and do B on this page. It's the cost of a golf ball at $2 a ball. So A, state the independent variable is the number of balls, and the dependent variable is the cost, because the cost depends on the number of balls. And again, for that you can have an N for the number, and you can have a C for the cost. Okay, I said I was going to do one at a time, right? Now, let's do A. For state three ordered pairs that fits the cost of a golf ball is $2. Well, if you start at 0, which you can, if you start at 0, then 0 times $2 is 0. If you buy one golf ball and it costs $2, so 1 times 2 is 2, so you pay $2. And if you buy two golf balls, 2 times 2 is 4. So the first one is your independent, which is the number of 0, 1, and 2. And the second one is your dependent, which is your cost of $0, $2, and $4. Okay, let's continue. And that is N, which is the number of balls, and C is the cost, because that's the variables they're going to use, N for number and C for cost. Then my table of values will have N and C. So that would be 0 balls, $0, 1 ball, $2, and if you got 2 balls, you're going to pay $4. And when you do the graph of this relation, then your horizontal axis is your independent, which is your N, and your vertical axis is your C, and that's your cost. So independent, the number of balls, gives you the cost. And when you do your graph, that's 0, 2, and 4. And that's 2 and 4 for the numbers, and 6. So when you draw your graph, 0, 0 is right there. 1, 2, 1 on the end. 1 ball costs $2. And 2 balls cost $4. Notice that these are points, because when you say counting, you can't go out and buy half a golf ball. You can only buy 1, none, 2, 4, 6, 10. So the graph here is a set of dots when you have discrete values, as in the cost of golf balls, $2. Here we go. Let's look at B, the number of sticks, excuse me, to form each diagram. So if this is diagram 1, this is diagram 2, and this is diagram 3, what we have here, we have 4 sticks. So we got 4 sticks to make this box. If we go over to this one, we have 4 sticks plus there's 3 more. So this box right here is the same as this one, but we add on so 3 more. And we take the next diagram, take this one, and we're going to add on 3 more, so we're going to get 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a pattern in forming these diagrams. Excuse me. So the independent variable would be the diagram number, the number of the diagram, as in the first diagram, second diagram, etc. And the dependent variable would be the number of sticks. to form that diagram. Okay, and the ordered pairs, well, here we go. I'm just doing 3 ordered pairs now. So we have diagram 1, and we got diagram 2, and we got diagram 3, because that's the independent. The independent in an ordered pair is the first one, and the second one is the number of sticks. 4 in the first one, 7 in the second one, and 10 in the third one. And notice that's, if you think about it, the diagram number could be D and the S number could be S. So that could be, if you think about it, that's D for diagram and S for the number of sticks. So we got 1 gives you a 4, a 2 gives you a 7, and a 3 gives you a 10. Now, if you want to do a diagram for that, again, the independent variable is the diagram, the number on the diagram, and the dependent variable is the S, which is the number of sticks. So, if you have 1 in diagram 1, we would have 4 sticks. So I have the number that's different because I don't have it high enough. So let's go with a 2, 4, 6, 8, 10, 12. Let's go with that. So 1 for your diagram. Diagram 1 would have 4 sticks. Diagram 2 would have 7 sticks. So that's 6, 7 is right in the middle of the 6 and the 8. And diagram 3 has 10 sticks. So you can see again, these are dots representing this what you call discrete data in relation to the two of these sentences. Okay, let's continue. Well, just then we talked about the table of values. But let me write down the table of values for A. So because they're on the other page, I'll just write them down what we have so you can see them. So if we have this table of values of these ordered pairs, what is the equation that represents this? Well, let's look back at this sheet. Notice that these points are on a line. They're linear. These points are linear. So because it's linear, that means that this equation is going to be in the form of y equals mx plus b, but we have in the first equation, we have an n and a c for each of the variables, n and c. So therefore, the x and the y that we have in this equation, which is the slope y-intercept form, is now being represented with an n and a c. So that means that the cost is going to be a function of n plus the b. But again, the b here is not a y-intercept. It's the point where this diagram starts from. And let me explain. Here we go. So how do I get the equation that represents the c and the n? C is cost, n is the number. So we still do what we call a slope. So the slope is, again, 4 minus 2 over 2 minus 1. It's like a y2 minus a y1 over x2 minus x1. So 2 over 1. And the slope is 2. Remember, it said that the cost of a golf ball was $2. So the slope is 2. So the cost is 2n. And as you can see in the diagram, that the y-intercept started at 0. So the equation that represents this relation, c equals 2n, because if you pay no money, if you look back at the diagram, which is this one right here, you notice that it starts off at 0, so the y-intercept is 0. Okay, let's continue. What's the equation for B? Well, the ordered pairs for B was 1, 4, 2, 7, and 310. And again, the equation for this one this was a D, which was the diagram number, and this was S, which was the number of sticks. So the equation now is y equals mx plus b is really S, which is the number of sticks, is the slope, and the diagram number plus the b, which is the starting point, but it's not called a y-intercept, it's called a vertical intercept. And let's see what that slope is. And remember now, when we looked at, let's go back, we had a 4 and a 7 and a 10, and if you notice, we can't start with no diagram. This one, you got to start with a 1. You can't start with a 0, because you can't start with no boxes. You got to start with one box. So the first ordered pair is 1, 4, 2, 7, and 3, 10. Okay, that means we have to come up with the equation, but there's no intercept this time. But let's see what we come up with. The slope is 10 minus 7, so it's 3 minus 2, and the slope is 3, which makes sense. If you look at it, you're going here 1, 2, 3 in order, so you're going from 4 to a 7, from a 7 to a 10, so you're adding 3. Every diagram is adding 3 more on each time, and the equation of this line, or the slope of this line, is, let's look at the first one. You are going 1, 2, 3, right 1, so the slope is 3. So you're adding on 3 sticks at a time. So that means, and not only that, you're not starting at 0, because we can't have a 0. We're starting at 4. We're starting at 4. So that means if you look at this equation and you go y like y equals mx plus b, so you have y equals, and your slope is 3, and your b is 4. So that equation is the number of sticks is the slope with the diagram plus the 4, because you're starting at 4. There's more work to be done on this, but I'm just trying to make some sense. And when you put it in the mapping form, you got a 1, a 2, and a 3, and that gives you a 4, a 7, and a 10. So 1 is mapped with 4, 2 is mapped with 7, and 3 is mapped with 10. That's the mapping rule, or mapping form on this. Notice the mapping is two diagrams with arrows going from one number to the next. So 1 is going with 4, 2 is going with 7. And again, you can see 4, 7, and 10. You can see that there's a 3 difference. You're going up by 3 each time because you're adding on 3 blocks. Let's continue. Continuous data is what we call data that's measured. Measured means it's continuous along the line. And the set of real numbers are all the numbers on the number line indicated by shading. So when you use continuous data in measuring the height of something or the length of time that you're running, and time is going on continuously. And if time is continuous, then your dependent variable is continuous. Let's explain about continuous data. The length of a leaf after a rate of 2 millimeters every week, beginning at 3 millimeters. Or we could have a volume of water in a container, if filling up at 1 liter every 3 minutes when it's empty. So notice time is going on every week, every minute, every 3 minutes. So when time goes on, then the volume of water is increasing, or the length of the leaf is increasing. So let's look at number 1. Let's do these again like I did before. Take A and work each out. Then I'll go back and pick up B and work each of these out. A, the length of a leaf at a rate of 2 millimeters every week beginning at 3. So your independent variable is time. And your dependent variable is the length of the leaf. If I can spell right. And the ordered pairs. So what happens? Notice you're beginning at 3. So the leaf is increasing 2 millimeters every week beginning at 3. So right now, if you have 0 time, then the leaf is 3 millimeters long. And if you have 1 week, after 1 week, then there's going to be 2 millimeters going to be added on to that, so that's a 5. And in the second week, week 2, you add 2 onto that, so it's going to be a 7. So it's going up 2 every week. So the table of values, and if we want time to be T, and we want length to be L, then we can use T as independent and L as dependent. So again, the ordered pairs, 3, 0 gives you 3, 1 gives you 5, 2 gives you 7, and the table of values is time in relation to the length. Again, that's time and that's length for each of these ordered pairs. And the graph, your independent variable is your horizontal axis, which is time. Your dependent variable is your y on your y-axis. And if you think about it, then this could be a 2, a 4, a 6, an 8, a 10, etc. And your height could be 2, or length 4, 6. The only reason I double these up is so I can get them all in there, because I have a small grid. So 0 seconds, that means your leaf 0 seconds, the leaf is 3 long. There's your a point. At 1 second, which is right here, that's 2 there, so 1 is right in the middle. 1 second is 5, so that's 3, 4, 5 is right here, so there's the dot right there. And 2 weeks, this is in terms of weeks. So the second week you have a 7, so that's a 6, so there's a 7. But the difference between the discrete was dots, but what happens here is that we're able to join these up, because as time goes by, we have a solid shading. In other words, we could talk about a half a second. We could talk about 1.8 seconds. So, or we can talk about 2.5 seconds. So 3 seconds would be right there. 2.1 would be right up there. Half a second would be right there. So this is shaded in, continuous. Continuous data is a measurement going on continuously. And let's go back and do the volume of water in a container filling up at 1 liter every 3 minutes when empty. Okay, what's the independent variable? Again, it's time. But this time is in minutes. And the other one, time was in weeks. And volume is your dependent. So the volume of water, which we're going to call V for volume, the volume is your because the volume that's in the container depends on how long you've been filling it up for, how many minutes. So the ordered pair for this one would be, and you're starting from empty. So that means if you start right now at 0 time, you have is empty, so it's going to be 0 when you start. And if you have every 3 minutes, it's going to be, it's filling up at a rate of 1 liter. For 3 minutes, you get 1 liter. And in 6 minutes, you have 2 liters. Because it's 1 liter for every 3 minutes. So 3 minutes is 1, 6 minutes is 2. And so your independent variable is time, and your volume, V. So you have 0, giving you 0 volume, 3 minutes giving you 1 liter, and 6 minutes giving you 2 liters. And the graph, T is the horizontal, volume is the vertical, like that's an X and that's your Y. So if you think about it, 0 gives you 0. 3, if you number these, is 3, and that's a 6, etc., and that's a 1 and a 2. So 3, again, this is in terms of minutes, so 3 minutes will give you 1. So if your volume is 1, 2, 3, 4, etc., and you got 3 minutes, you get 1 liter in terms of your volume or capacity. And you got 6 seconds, you have a 2. But again, as time goes by, 1 second would be probably there, 2 seconds would be there. It would be 1/3 and 2/3. So the line is drawn through these points, and there's the line. And the line is what we call continuous, shaded in, real numbers, because as time goes by, the volume is increasing. So it's a solid line. And notice the slope. 1 liter every 3 minutes. So the slope is, right here in the first one, is 2 millimeters for every week. So 1 week. So that's millimeters. And the time is 1 week. So that's that's your rate. Rate is your slope. Or right here is filling up at 1 liter every 3 minutes. Again, that's a slope. It's rise of 1, a run of 3. But the rise is in terms of the volume, and the run is in terms of time. Let's continue. Now, as in just then, the ordered pairs that you don't see, I'm going to put them here for you so that you can see it and see what I'm talking about. We have these ordered pairs, and again, this is your T and this is your L. So the equation, we have to get the slope. Again, the equation we're looking for is y. I always relate to y equals mx plus b. But remember, the y is L and the x is your T. And we think about that as your intercept. That's in terms of your length. So the slope is 7 minus 5, y2 minus y1 over x2 minus x1. I say that, but it's really, this is the length and your time. This is the length and your time. So this is T1, L1. This is T2, L2. And that gives me 2 over 1, which is 2. And that makes sense because if you look at it from the sentence point of view, the rate is 2 millimeters every week. So that's 2 over 1, but it's millimeters per week. So the slope is 2 over 1. And if you look at your graph and your y-intercept, this starts off at, it's beginning at 3, it says, and the graph says it's beginning at 3. The table of values got us 0, 3. So it starts off at 3 as your y-intercept. So the equation is L equals 2t plus 3. And again, notice that when time is 0, you get a 3. So that's your intercept, or what it's starting off at. B, you have the ordered pairs of 0, 0. You have a 3, 1. And you have 6, 2. And I always relate y equals, I always go back to what I've learned with the x and y as slope by intercept form. And now this equation was, this was t and this was v. So this is t1, v1, t2, v2. So this is a v and that's a t. I'm going to fill in my slope and my intercept. So the slope is M for slope. The slope is V2, which is 2, minus V1, which is 1. And T is, T2 is 6, minus 3. So the slope is 1 over 3. And the slope is 1 over 3. Let's look. It says you're filling up 1 liter every 3 minutes. So that's a 1 liter over every 3 minutes. So that's 1/3. So that makes sense in relation to the sentence. So, and our intercept says is starting off, if you notice our graph or you notice the sentence, when empty. So when empty means there's no water in the container. Or we look at a graph, we got 0, 0. So there's the volume is 0. So we have our slope is 1/3 and starting off as 0. So the equation is 1/3 t plus 0 because it's starting off as 0. V equals 1/3 t. So as we got 0 minutes, 1/3 times 0 is volume of 0. You got 3 minutes, 1/3 times 3 is 1. You got 6 minutes, 1/3 times 6 is 2. That fits in with these ordered pairs. And we have a 0, a 3, and a 6. That gives me 0, 1, and 2. So note, this is, if you think about it, that's your time and that's your, I wrote volume, right? Because we're doing the second one here. We did the first one already. Oh, I better put down, this is the second one. So I hope, sorry, 1, that's a 1, and that's a 2, that's the first one. That's a 3, a 5, and a 7, because that's my L and T, sorry. And this is T and V, so this is 0, 3, 6, gives me 0, 1, 2. Sorry about that, I didn't put the second diagram, I was going on with this one that I just did. So this is the first one, that's the A in relation to the length of the leaf, and this is B in relation to the volume. And again, they're mapped. 0 goes with 3, 1 goes with 5, and 2 goes with 7. 0 goes with 0, 3 goes with 1, 6 goes with 2. Okay. And practice means pause the video and see how you're going to make out with doing these. Here we go. If you have them done, press play. The fee for a golf season is $200 down plus $100 a round. So your independent variable is the number of rounds. And I'm going to call the number of rounds R. R for rounds. The dependent variable is your fees, or your cost if you want. And I'm going to call F for fees or costs. So how much money you pay in the season depends on how many rounds you pay. But notice, you're paying $200 up front. So you're starting off at 200, and then as time, number of rounds you play, your fees is going to be more and more and more. And when you're doing the number of rounds, that's discrete, because you don't pay when you golf. You can only pay for 1 round, 0 rounds, 2 rounds. So it's possible, if you think about it, if you pay your $200 for your fee and something happened, then you would pay no more. So you start off at 200. If you did 1 round, you would pay $100 plus 200. If you played 2 rounds, you would pay 200 plus the 200, $400. So it's discrete. It's not continuous. It's dots. And we have R for rounds, and we have F for fee. So if we do no rounds, we have to pay $200 anyway. If we have 1 round is 1 times 100 plus the 2. So that's plus 200, so that's $300 you pay. If you do 2 rounds of golf, then you pay 2 times 100 plus 200, so you pay 400. So notice you're going up by 100 each time. Each, obviously, $100, right? And that's for 1 round of golf per round. So that's a slope. And if you did your graph, your rounds would be here, and your fees would be here. But what happens, notice you can't be over here. You can't have a negative round, -1, -2, -3. So you can't be on this side. And you can't be down here because the money that you're paying is not negative. So your graph has to fit in here. So if you do 0, 1, 2, 3, 4, and that's $100 instead of $300 and $400. So 0, you're starting off at $200. You play 1 round, you're going to pay $300. You play 2 rounds, you're going to pay $400. So 3 rounds, it goes up by 100. You go up 100 and to the right one for every round. So there's the dots going on, but it's discrete. It's dots. You can't shade this in because you don't pay for half a round or 3/4 round. And the equation, if you think about it, is y equals mx plus b. So think about it. You have your phi, which is your y, and you have your r, which is your rounds, and you're paying $100 because that's your slope. You're going up 100, right one, and you're starting off at $200. So if you took the ordered pairs and worked it out, then this is what you would get, but you can see that from your graph. Number 2, air leaks from a balloon at a rate of 2 cubic meters per hour. The volume of a balloon starts at 10 cubic meters. And remember, the air is leaking out. So that means the volume is going down. And the rate is 2 cubic meters per hour. So let's see. Let's go through this. Independent variable. Again, your independent variable is your time. The time, and we're going to call time t. Your dependent variable is the volume. And the volume of air, we're going to call V for volume and T for time. So as time goes by, then we have a certain amount of air left in the... So, let's see, let's do, is it continuous or discrete? Is this dots? Because time is measured, because it's going on for a half a minute, minute and a half, 2 minutes, etc., then we have continuous data. That means it's going to be shaded. And that means your independent is time and your dependent is volume. That's like an X and a Y. So that means T is on the horizontal, V is on the vertical. And again, we can't be on this side of the graph because we can't have negative time. We can't be over here on this side. And we can't be down here because the volume, once the air is leaked out, then the volume has to stop at 0. So let's see what we have. It's as a rate of 1. So we have a slope. So if we have 0 seconds right now, when you start, the balloon has 10 cubic meters. It goes down 2 cubic meters per hour. So 1 hour is 2 off of that. So it's 8. The next hour, there's 2 more of it. So 6. 2 hours, there's 4 cubic meters gone. So there's 6 left. If I did a 3, I would get a 4. And if I just continue with that for a second, what happens is that, if you can see, 4 gives you a 2. And 6 hours, you get 0. Or sorry, 5 hours. I got to keep it straight. So I got a 0, 1, 2, 3, 4, 5. So after 5 hours, you would have no air left in the balloon. So 0, it starts off at, let's go 2, 4, 6, 8, 10. And the time is 1, 2, 3, 4, 5, 6. That's in hours. Time is in hours. The volume is in cubic meters. So 0 time starts off at 10. and 1 hour is 8. 2 hours is going down, 6. 3 hours is 4. 4 hours is 2. And 5 hours, there's no more air left in the balloon. And notice it's continuous because its time is always changing. So it's a solid line, and there it is. It goes from 10 when the balloon is full to when it's empty. Empty is 5 hours. So the equation is like y equals mx plus b, but what happens? The volume is your y, x is your time, and notice you're going down, so that's a minus 2, and you're starting off at 10. So from the graph. But if you did the ordered pairs, which is the same thing, so if you got 0 giving you a 10, 0 time starts off at 10. That's your y-intercept at 10. And if you want to figure out your slope, because it's going leaking out, is minus 2, but that's an 8 minus 10 and 1 minus 0, so that's a negative 2 over 1. So the slope is negative 2, which is what we knew because it's leaking out. So the slope is negative 2 if you use your ordered pairs. So that's trying to relate how to come up with the equation, what we call in real life problems. Not in terms of x and y, but in terms of volume and time, or fees and time, etc., etc. If you like my video, click the like button. If you're not a subscriber, you can click the subscribe button, join my channel, and the notification bell. Write a comment on my video if you wish. And don't forget to visit my math website, mathfullyexplained.com. And 3 sections, me talks about my degrees and teaching experience. The video talks about the strategies you're going to use to help you learn your math. And the section on content talks about the topics I have on my YouTube channel, plus the number of videos on those topics. The black font is what's online right now, and the red font is what's online, will be online in the near future. Thank you for viewing my video. Bye-bye.